Let's go over our triads. So our 6 is our numerator that goes on the inside, and then on the outside goes our denominator. So 5 goes into 6 one time, and 1 times 5 is 5. I'm going to subtract these and I get 1. Since that's not a 0 and I don't see a pattern yet, I'm going to add a decimal next to my 6 as well as next to my 1. So I'm going to draw one right above it, and then I fill in a 0. And that's so you can bring it down. So 5 goes into 10 2 times. 2 times 5 is 10. I subtract, and I get 0. So my answer is 1 2/10. So 6/5 is equal to 1 2/10. All right, so with a mixed number, we need to turn it to an improper fraction. So we multiply 8 times 7, and we add that to 3. So that's going to give me negative 59, because 8 times 7 is 56, plus 3 is 59, over 8. 59 goes on the inside, and then 8 is on the out. 8 goes into 59 7 times, and that's 56. I subtract, and I get 3. I'm going to put a decimal and a 0 to bring down. 8 goes into 30 3 times, and that is 24. When I subtract, I get 6. And then I'm going to add a 0 to bring down. 8 goes into 60 7 times, and that is 56. I subtract, and I get 4. And I don't see a pattern yet. For all we know, that 7, there's something different that comes after it. Now I have a 40. 8 goes into 45 times. I'm glad that I did not stop there, because when I subtract, I get 0. And so now I find out that my decimal is negative. Remember that negative. It has to be put on your answer. 7. It's a rough 7. Negative 7 and 375 thousandths. So this is my answer for my decimal, which is the same as down here. Maybe that kind of helps a little bit. All right. Next one, we have 3 is our numerator. That goes on the inside. 11 is our denominator. 11 does not go into into 3. So we are going to decimal and add a 0. And now 11 goes into 30. 2 times 7 times, 2 times 11 gives me 22. 30 minus 22 gives me 8. 11 does not go into 8, so I'm going to add another 0 and bring that down. 11 does go into 80, and that's 7 times. 7 times 11 gives me 77. When I subtract, I get 3, so I'm going to bring down my 0. 11 goes into 32 times. I'm starting to see a pattern happening. And that, when I subtract those, I get 8. And again, I bring that down. Oh, we got 80 again. So that's 7 times that 11 goes into 80. That's 77. And I get 3 again. So we got a pattern happening here. And then don't forget that negative goes in front. So here's my pattern, and it's going to go on forever and ever and ever. So to show that as a decimal, we are going to do negative 0 and then 27 hundredths repeating. So that's going to go on forever. At 27 repeats. All right. And then last one, we are going to do 27 times 1. and then add 5. So 27 plus 5 gives me 32 over 27. And so now I am going to put the 32 on the inside, and then the 27 goes on the outside. 27 goes into 32 one time. I'm going to extend this because I already have a feeling we're going to go over. 1 times 27 is 27. Subtract those, and I get 5. I'm going to have to put a decimal here and bring down that 0. 27 goes into 25 one time again. 1 times 27 is 27. When I subtract those, I get 23. But 27 doesn't go into 23, so I have to bring down another 0. 27 goes into 230 8 times, and that is 216. When I subtract that, I get 14. 27 does not go into 14, but it does go into 140. And it goes into that 5 times, and that gives me 135. In which when I subtract, I get a 5. And when I take a 0 and bring it down, now I have a 50, and now that's going to be the same thing again. And so that means that I'll get a 1 here, right? And then an 8, and then a 5, and it's going to go on forever, ever. So that means that I can rewrite this decimal as, oops, I forgot my 1 in there. There we go. And then the line has to go above the 1, the 8, and the 5. So that bar notation can go over multiple numbers. It can go over 2 numbers, 1 number, 5 numbers. It doesn't matter as long as it covers the whole pattern. And so now we have all 4 of those answers. All right. Go to the next video to learn about writing terminating decimals as fractions.